Hello there. So with iteration statements and jump statements done, now is the time to solve some questions using iteration statements. Now, there can be a lot of questions that we can solve using iteration statements. So I have handpicked a few with an objective that we cover all possible patterns of questions that we can solve using iteration statements. Not all possible questions, but all possible patterns of questions. So that led me to have a few questions that you can see over here. Now, I have categorized these questions into four broad categories. The first one, that is the fundamental loop patterns, which contains all of these questions, is what I'm going to cover in this video. And the objective of solving these questions is to make you comfortable with iteration statements. Now, once we are done with that, we will move on with the questions in the next category, which is the digit extraction patterns, where what are we expected to do is, given a number, we're expected to extract digits from the number and process those digits. Then we will have another category of questions, which I have named as mathematical loop patterns, where we will solve some mathematical questions. For example, finding all divisors of n, or finding x power n, or determining if a number is a prime number or not, etc. And by the way, the names that you see over here, for example, fundamental loop patterns or digit extraction patterns, etc., are the name that I have given. These are not the standard names. Anyway, once we are done with these three, we will then move on to solving some questions using nested loop. And like you can see, it is still a work in progress, but I will finalize the list of questions very soon and I'll update the list. And by the way, this is my favorite category because we can print many beautiful patterns using nested loop. But we will get to this later. For now, let's focus our attention to the first category of question that we are going to solve today, which is the fundamental loop patterns. And let's start off with the first question in this category, which is, given a positive integer n, we need to print all numbers from 1 up to n, right? So the question is pretty simple. So let's jump to IntelliJ, where I already have a package called src, inside which I have a package called iteration statements. Now, inside iteration statements, I'll create a new package and I'll name this as questions. And inside this, I'll have another package and I'll name this as fundamental underscore loop underscore patterns. And inside this, I'll create a Java class and I'll name this as q1 underscore print all numbers from 1 to n. And over here, I'll have a main method. Now, to print all numbers from 1 to n, we'll have to iterate from all numbers to, from 1 to n, right? And we already know how can we do that. So we will have to say for int I is equal to 1, I less than equal to n, and I plus plus. So what will happen here is I will start from 1, will go all the way up to n, and it will increase the value of I by 1 in every iteration, right? And of course, we'll have to declare the variable n and initialize some value to it. Now, of course, we can take the value of n as an input from the user, but I'll leave that on to you. For now, to keep things simple, let me hard code this to 10. Now, once we are done with these, what is the next step? The next step is to print the number, right? And that number will be in variable I. So inside the for loop, we can say system.out.println I, right? Now, if I run the code, what is the expected output? The expected output is 1 all the way up to 10 printed on the screen, and all of them will be printed in separate lines, right? Because we have used println. So if I run the code, I should get 1 to 10 printed, and that's what we are getting. Now, if I change the value of n from 10 to, let's say, 27, I should get 1 to 27 printed on the screen, right? And that's exactly what is happening. So this is how we can solve the first question, which is to print all numbers from 1 to n given the value of n. So we're done with the first one, right? So with this clear, let's move on to the next question, which is, given a positive integer n, we need to find sum of all numbers from 1 to n. So before we write code for this, let's understand how can we approach this question. So what are we given with? We are given the value of n. So let's assume the value of n is 5 for now, right? So given this, what we have to do is we have to find this, right? Because the value of n is 5, we have to find 1 plus 2 plus 3 plus 4 plus 5. And if the value of n was, say, 50, for example, we would have to find 1 plus 2 plus 3 plus 4 plus 5 all the way up to 50, right? So pay attention to the fact that this is what we are given. So we'll have to reach a point where we get this, right? So let's discuss how can we do that. Now, if you take a look at what is given and what we need, you would be able to figure out that given n, we somehow have to get all numbers from 1 to n, right? Only when we have all numbers from 1 to n, we can go for addition, correct? Now, we have just solved a question where we did exactly that. That is, given a value of n, we iterated from 1 all the way up to n, and we printed those values also, right? So let me quickly put that code over here, which was for I is equal to 1, I less than equal to n, I plus plus. And over there, what we did was we printed the value of I, right? So in every iteration, I will hold a number, and that number will start with 1 in the first iteration, then will become 2 in the next, 3 in the next, 4 in the next, and 5 in the last iteration, after which the value of I will be 6, and this condition will be false. And because of that, the loop will terminate, right? So given this, we know how can we reach this. That is, how can we get all of the numbers from 1 up to n. Now, there's another challenge over here, and that challenge is we have this, but what we need is this. That is, to be able to add all of them. And the challenging part here is we'll get each numbers one by one, right? So if we get each number one by one, that is, I will first of all be 1, then 2, then 3, then 4, and then 5, which means when we have the value of I as 3, we will have only 3. We won't have 1 and 2, right? How do we find the sum? So for that, let me give you a simple scenario on the basis of which I'm going to discuss the next steps, right? So let's say there are two persons, say P1, or let me name this as I. Let's say the person's name is I. And then we have another person. And let's say the person's name is Sum. Now, let me explain the roles of I and Sum over here. What I will do is I will give numbers one by one to Sum, right? And let's say, as the name suggests, the role of Sum would be to keep track of sum of all the numbers that I has given so far, right? So for example, if I gives 1, Sum will keep track and will say 1 because I has given only one number. And if I has given only one number, the sum will be that number itself, right? So I gave 1 and Sum says 1. Now I gives 2. So when I gives 2, I has given 1 and 2 so far, right? So Sum should keep track of the sum and it should be 3, right? Then when I gives 3, Sum should have 6, correct? So how will this be possible? That is, how will it be possible that I gives number one by one and Sum keeps a track of the sum of numbers that I has given so far? So for that, take a look at whatever we have over here. And you'll notice that every time I gives a number, let's say 4, what Sum can do is Sum can take the sum so far. That is the sum that has been calculated so far, then add the new number and keep a track of new sum, right? So for example, if I gives 5 right now, what will Sum do? Sum will take the sum so far, which is 10. And how did we get 10? We get 10 by keeping track of sum of all the number that I had given earlier, right? So when I gives a new number, Sum will have the sum so far, which is the sum of all the numbers that I has given so far, right? So Sum can take that, add the new number, which will give a new sum, and then keep a track of that sum only and not the previous sum, right? So if I and sum works this way, sum will be able to keep track of sum of all the numbers that I has given, right? Now compare this scenario to what we have over here. What I was doing over here, that is what this person named I was doing, was it was giving numbers one by one, right? And sum was keeping track of some of the numbers so far. So when I gave 1, sum said 1. When I gave 2, sum said 3. I gave 3, sum said 6, and so on. And that's exactly what we will have to do to solve the question, right? Because we just realized, I mean, not just, we realized a few minutes back that given n is equal to 5, we have a way to get all of the numbers from 1 all the way up to n, right? So given this, we can get this. But what we ultimately need is this, that is to add all of the numbers. And another challenge over here is that we will get each number one by one. And when I get one number, for example, 3, I won't have 2 and 1, for example. Similarly, when I get 5, I won't have 4, 3, 2, and 1, for example. So we will have to keep a track of all of the, of the sum of all of the numbers so far, right? Which means that by the time I give 5, I somehow will have to keep track of all of the numbers from 1, sum of all of the numbers from 1 to 4. Similarly, when I give 4, sum should contain the sum of numbers from 1 to 3 and so on, which is exactly what we have discussed just now, right? So what we can do is, we already have a variable called I. All we will need now is to declare a variable called sum, which will keep track of the sum, right? And what did we discuss about keeping track of the sum? We discussed that when I gives a new number, what will sum do to find the new sum? When I gives a new number, sum will take the sum so far, add the new number, and get the new sum, right? So if I gives another number the next time, which is 5, for example, and we are assuming that I has already given 1, 2, 3, and 4, what will happen at this point is the sum so far was 10. So 10 and 5 will be added to get 15, and sum will hold only 15, and it won't need to hold all of this, right? So what does this tell us? This tells us that the new sum will be equal to old sum plus the value I, right? That's what we did. This was the old sum. So to calculate the new sum, we took the old sum, and what did we do? We added 5, that is a new number, which is I, and then we got the new sum. Now, one challenge over here, and not a challenge actually, just something that we should consider, is that there's only one variable called sum. We are not taking two variables. Of course, we can, but then all we need to do is store the current sum, right? So there's no point taking two variables. We can do it using just one variable. So if I were to replace this statement to use just one variable, what would that statement be? That statement will be sum is equal to sum plus I, right? Because when we are going to perform this operation, this variable, that is sum, will contain the old sum, right? And when we add I to it, we get new sum. And then when we finally store the result of this addition in the same variable, we will be getting the new sum, where what will happen is the old value will get replaced with the new one, right? So I hope it is clear that ultimately we will be going for sum is equal to sum plus I. Of course, we can go for new sum is equal to old sum plus I, but let's go for this. So again, coming back to the question, what are we supposed to do now? When I is equal to 1, we are supposed to go for sum is equal to sum plus I, right? Now, over here, sum does not have any value. So what should the initial value of sum be? Because to perform sum is equal to sum plus I, you would need some value in this, right? But when the value of I is 1, sum does not have any value. So if sum does not have any value, what should the initial value be? I would say the initial value should be 0. Now we will get to y in a moment, but for now, let's consider the initial value to be 0 and see if it is working well or not. So if sum is equal to 0, and if we go for sum is equal to sum plus I, let's see what happens. So sum is 0, I is 1, 0 plus 1 is 1, and we go for sum is equal to sum plus I, which means we calculate 1 and we store in sum, which means sum is no longer 0, it is 1, right? Now, the next time I is equal to 2, what are we going to do? We're going to go for sum plus I, which will give us 3, and we're going to store it back in sum, right? So the value of sum would be 3. And similarly, in the next iteration, when I is 3, we'll go for 3 plus 3, which will give us 6. So sum will be 6. Similarly, next time sum will be 10, and next time sum will be 15, and then the value of I would be 6. And when I is equal to 6, this condition will become false. And if this condition becomes false, the loop terminates, right? And when the loop terminates, over here, that is right after the loop, we will use the variable sum to print the value of sum of numbers from 1 all the way up to n. So I hope this is clear. And if it is, now let us get to the discussion of why did I initialize the value of sum to 0. Now think of it this way. When I give one number, the value of sum becomes 1. When I give two numbers, which is 1 and 2, the value of sum becomes 3. Because I've given a few numbers, and when you add those numbers, you get a certain value, which will be the sum of those numbers, right? But when I have not given you any number, what will the value of sum be? In that case, the value of sum will be 0, right? Again, because I've not given you any number. And the moment I give the first number, which is 1, the value of sum becomes 1. The moment I give you the second number, that is 2, and assuming that I've given 1 so far, the sum becomes 3. And that is how it proceeds. So when I have not given you any number, the value of sum would be 0, right? Now, if you want to understand this more mathematically, it has to do with additive identity. And because additive identity is 0, we initialize sum to 0. Now, if you're wondering what additive identity is, it is simply a number which, when you add to another number, gives the same number. For example, if I have A and I'm expected to add a number such that I get A at the end, what would this number be? This number would be 0, right? So 0 is the additive identity. And because of that, we initialize sum to 0. So with all of this clear, let's go to IntelliJ and close this, create a new Java class. Let's name this q2 underscore print sum of numbers from 1 to n. And over here, let's have a public static void main, and let's start writing the code. Now, what did we discuss? We discussed that the first thing that we would need is to iterate from 1 all the way up to n, which essentially is the code that we had written in the last question that we had solved. So let's declare n to be 5, for example. And according to our discussion, we would also need a variable called sum, and we will need to initialize this to 0, right? And then inside the loop, what are we supposed to do is, we're supposed to do this, where what are we doing is we're taking the older value of sum, because again, by the time this statement evaluates, it will first of all evaluate the right hand side, right? So when it evaluates the right hand side and it gets the value of sum, this will be the older value of sum, right? And to the older value of sum, we will add the value of I, and then we will store the result in the same variable, which is sum. So this is what we are supposed to do. And like we had discussed, at the end of the loop, we will have the value of sum of numbers from 1 to n in the variable sum, right? So what are we going to do here is we're going to print the value of sum. Simple. So if I run the code, what do we expect? We expect 15, because the value of n is 5, which means it is 1 plus 2 plus 3 plus 4 plus 5. And if you go for 1 plus 2 plus 3 plus 4 plus 4 plus 5, you'll get 15. And that's exactly what we are getting. And if I change this to 6, for example, I should get 21, right? And that's exactly what we got. Now, as you might have observed already, and you might be thinking, this is similar to a math problem that we already know, which is to find sum of first n natural numbers, for which we have a formula, which is n multiplied with n plus 1 by 2, right? So I completely agree with you. But what we are trying to do over here is we're trying to get comfortable with iteration statements. And that is why I have solved this question using iteration statements. But if you're thinking that we can just put the formula and get the answer, you're absolutely right. But again, for now, let's keep the code this way. That is using iteration statements to iterate from 1 to n and finding the sum of numbers. So with this done, we are done with the second question also, which is to find sum of all numbers from 1 to n. So let's mark this as completed. And then let's move on to the next question, which is to print all even numbers from 1 to n. Let's come back over here and let's discuss how can we solve this question. And for that, let's take the value of n is equal to 5. So what are we supposed to do is from 1 to n, we will have a few numbers and we're supposed to print only even numbers, which means the output should be 2 and 4, right? Now, if the value of n was 6, for example, the output would have been 2, 4, and 6, which means if n is an odd number, we will go until n minus 1. That means the last number that will get printed will be n minus 1. But if n itself is an even number, we will print the value of n also starting from 2, right? So now let us break this question into simpler parts. So we have n is equal to 6, and we know that we have a way to print all the numbers from 1 to 6, for example, assuming that n is equal to 6, right? So we can print all of this. But for this question, what are we interested in is we're interested in only the even numbers, right? So this brings another problem. And that problem is given each number, that is value of I 1 by 1, how do we determine if the value of I is an even number or not? And we already know how to do that, right? So given the value of I, can we say this? If I mod 2 is equal to 0, it is even, right? So I can be 1, 2, 3, 4, 5, and 6, right? Now, if I take the value of I divide the value of I by 2 and check if the remainder is 0 or not. And if the remainder is 0, can we conclude that it is an even number? We can, right? So again, starting from the very first, we will be given the value of n. And given the value of n, we know how to print or how to access all of the numbers from 1 to n, right? Now for this question, we're interested in printing only the even numbers. So we can get only the even numbers with this code, where we check the remainder when we divide I by 2 and compare and see if it is equal to 0 or not. If it is equal to 0, it is even, which means if this condition is true, we can go for this statement, right? That is system.out.println I. But if this condition is not true, we won't print, right? So with this logic, will we be able to solve the question? Well, I think yes, but let's see. So let's come back to IntelliJ. Let me close this. Let's create a new Java class and name this as q3 underscore print all even numbers from 1 to n, right? And let's go step by step. First of all, we need the value of n. So let's say it is 6. And then let's go for this. Int I is equal to 1, I less than equal to n, I plus plus. Now, what are we supposed to do? We're supposed to print the value of I if I is an even number, right? And for that, this is what we will say. We'll say if I mod 2 is equal to 0, then system.out.println I. Now that's what we had discussed, right? So let's run the code with the value of n is equal to 6 and see the output. And we expect the output to be 2, 4, and 6, right? And that's exactly what we are getting. Now, if I change this to 5, what should the output be? The output should be 2 and 4, correct? And that's what we got, which means the logic that we had discussed is working absolutely fine, right? Now, this is just one of the ways to solve this question. And there's another way, a simpler one. Let's talk about that. So for that, let's come back over here. And what did we discuss was, given n, we can iterate from 1 all the way up to n, where the value of I will increase by 1 in every iteration, which means, first of all, it will be 1, then 2, then 3, then 4, then 5, and then lastly 6. Now, when we are supposed to print even numbers from 1 up to n, which will be the first even number that gets printed? Every single time, the first even number that will get printed is 2, right? 2 is the smallest even number, correct? So if we do it this way, where we start with 2 instead, because we know that if we start from 1, 1 will not get printed. So that iteration in a way is waste, right? So if we start with 2, that is a little more useful, right? So we start with 2 and we print 2. Now, if we jump from 2 to 3, this will not get printed because 3 is not an even number, right? But can we jump from 2 to 4? So we start with 2 and we jump straight to 4. Can we do that? Yes, we can, right? What we had done was, we had this loop where we had written for I is equal to 1, I less than equal to n, I plus plus. And because of this I plus plus, we were jumping from 1 to 2, then from 2 to 3, then from 3 to 4, and so on. Now, what did I say? Let's change the value of I to not start from 1, but to start from 2. So we will start from 2, right? But then if we keep on doing I plus plus, we will jump from 2 to 3, then 3 to 4, then 4 to 5, and so on. But what will help is jumping from 2 to 4, right? So this I plus plus, which we know is similar to this, that is I is equal to I plus 1, is causing the value of I to increase by 1 every time. But what if instead of going for I plus plus, which is equivalent to this, I go for I is equal to I plus 2. If I do this, which can also be written as this, what will happen? We start from 2, right? Then instead of I plus plus, we will go for I plus equal to 2. So from 2, we will go to 4. Then from 4, we'll go to 6. And this will ensure that we start with the smallest even number, and then in every iteration, we'll land on another even number. That is the next even number, right? So even this will help in solving this question. And over here, we will not be iterating and reaching numbers which will ultimately not get printed, right? So with this clear, let's come back to IntelliJ and let's rename this. And let's say Q3 underscore print all even numbers from 1 to n underscore solution 1. And I'm going to copy this, and then I'm going to refactor this so that the name changes. And then I'm going to create another Java class, paste that, and I'm going to change this to solution 2 and hit enter. Now, once I hit enter, what am I going to do next is copy the main method from here, and I'm going to paste it over here. Now, as we had discussed, what we should be doing is we should be starting from 2, right? And we should not be increasing by 1 in every iteration. We should be increasing by 2. And if we do that, there's no need of this condition, right? We can straight away print the value of I, because we know it will start from 2, then the next value of I will be 4, then 6, then 8, and then 10, and so on, right? So if I run this code with the value of n is equal to 5, we should get 2 and 4. And that is exactly what we got. But if I run this with, say, n is equal to 6, we should get 2, 4, and 6. And that is what we have got, right? So even this solution is working absolutely fine. So with this, we're done with the third question from the list, and we discussed 2 solutions for it. So let me mark this as done. Now, let us move on to the next question, which is, given a positive integer n, what are we supposed to do is we are supposed to find sum of all even numbers from 1 to n. So if you take a look, this is in a way a combination of whatever we have discussed so far, which is finding sum and finding sum of all even numbers from 1 to n, right? So the solution is going to be pretty simple. And that is why let me jump straight to IntelliJ, and let me first of all keep both solutions side by side. And let me discuss that first over here. Now, take a look at the first solution. Here, what are we doing is we are iterating from 1 all the way up to n, where every time the value of I will increase by 1. And then we are checking and printing, which means the code that is inside the body of if will execute if and only if the value of I is 1, right? So over here, because we are supposed to find sum of all the even numbers from 1 to n, what can we do is we can do what we did when we were supposed to find sum of all numbers from 1 to n. That is, declare a variable called sum over here, right? And then go for sum is equal to sum plus I inside the body of if, right? And that will be required if we are going for the first approach that we discussed for printing all even numbers from 1 to n. But if we are going for the second approach, over here, we don't have any if, right? So all we will have to do is we'll have to create a variable called sum over here, that is after int n is equal to 6, initialize the variable sum to 0, and over here just go for sum is equal to sum plus I, right? Because in the second solution, we are starting from 2, then going for 4, then 6, then 8, and so on. So if we have 2, 4, 6, 8, and so on, we can just go for sum is equal to sum plus I, right? So with this discussed, let me close these two and let me expand this a little bit. And let me, first of all, copy the name from here and let me create a new Java class and paste this. And here, what am I going to say is Q4 underscore, instead of print all even numbers from 1 to n, I'm going to say print sum of all even numbers from 1 to n. And I'm going to say solution 1, because like you might have guessed, we're going to write two solutions for this. So for this, let me grab the main method from Q3 solution 1 and let me paste it over here. And over here, what am I going to do is I'm going to create a variable called sum is equal to 0. And here, instead of printing, I'm going to say sum is equal to sum plus I, right? And at the end of the for loop, I'm going to print the value of sum. So if n is equal to 5, the even numbers will be 2 and 4. So the sum should be 6. And if I run the code, that's what I get. Now, if I change the value of n from 5 to 6, I should get 2 plus 4 plus 6, which is 12, right? So if I run the code, that's exactly what we have got. So that means this solution is working perfectly fine. And because this is working perfectly fine, let's close this. Let's create a new Java class. And that Java class will be for the second solution that we're going to put. So we are going to say Q4, and we're going to say print sum of all even numbers from 1 to n, solution 2. And over here, let me grab whatever we had in Q3 solution 2. Let me close this. Let's come back here, paste the main method. Let's create a variable called sum initialized to 0. And instead of system.out.println, let's say sum is equal to sum plus I. And at the end, let's print the value of sum. So if I run the code with n is equal to 6, I should get 12. And I am getting 12. And if I change this to n is equal to 5, I should get 6. And that's exactly what we are getting. So with this, we're done with the fourth question from the list, which is to find sum of all even numbers from 1 to n, right? So let me mark this as completed. Now, let's take a look at the next question, which is given a positive integer n, we need to print the multiples of 3 between 1 and n. Now, this seems similar to the previous question, right? In the previous question, we were printing all even numbers. So printing all even numbers from 1 to n is like printing all multiples of 2 between 1 and n, right? So all that we had changed, we have changed in the fifth question is printing the multiples of 3 instead of multiples of 2 like we did in the last question. So this must have given you an indication that the code is going to be largely the same, right? So if I come back over here and I open Q3 solution 1 and Q3 solution 2, and I keep them side by side, what do you see? Over here, we're dividing by 2 and checking if the remainder is 0, because we were supposed to print the multiples of 2, right? So if a number is a multiple of 2, it will give 0 when you divide that number by 2, correct? So if we were to do the same thing for multiple of 3, we should be replacing this I mod 2 is equal to 0 with I mod 3 is equal to 0, right? Or what we can do is, like we did over here, we started from 2 and went all the way up to n, and we increased the value of I by 2 in every iteration. And again, that was done because we were supposed to print all the numbers, all the even numbers from 1 to n. And even number means multiples of 2. Now we need multiples of 3. So the first multiple of 3 will be 3. So instead of setting I is equal to 2, we will set I is equal to 3. And instead of incrementing the value of I by 2, we will increment the value of I by 3. So if we do that, we will be able to solve this question as well, right? So what am I going to do next is I'm going to take the code that we already have, as in copy and paste, make certain modification, and then see if the solution is working fine or not. So the first thing that I'm going to do is I'm going to say rename, copy this, and I'm going to create a new Java class. I'm going to paste it. I'm going to say Q5, and I'm going to say print all. Instead of even numbers, I'll say multiples of 3 from 1 to n and solution 1. And over here, since we are going for solution 1, I will just copy the main method from Q3 solution 1, come back over here, paste it over here, and I will say if I mod 3 is equal to 0, then I'm going to print the value of I. Now let me increase the value of n to, for example, 14. And if I run the code, I expect 3, 4, 6, and 12 to be printed, right? So if I run the code, that's exactly what I'm getting. And I'm sorry, it should not be 3, 4, 6, 12. It should be 3, 6, 9, and 12, right? So the code seems to be working absolutely fine. Now, if I change this to 15, for example, I should get 3, 6, 9, 12, and 15, right? And that is exactly what we got. So with this done, let's move on to the next solution. And the next solution is going to be whatever we have discussed. And for that, we will first of all create a Java class, and we will say Q5 print all multiples of 3 from 1 to n, solution 2. And to write the code and to make it fast, I'm going to copy the main method of Q3 solution 2. And I'm going to come back over here. I'm going to paste it over here. And I'm going to make certain changes, which is I will start from 3 and I will increase by 3 every time. Now let me change the value of n to say 14 and then run the code and expect 3, 6, 9, and 12, right? And that's exactly what we got. Now let me change this to 15 and then run the code and expect 3, 6, 9, 12, and 15. And that's exactly what we're getting, right? So both the solutions that we had discussed seems to be working absolutely fine, which means we are done with the fifth question also. And since we are done with the fifth question, let me mark this as completed. And with this, let's move on to the next question, which is given a positive integer n, we need to count the multiples of 3 between 1 and n. So this might have told you that this is going to be similar to the last question that we have solved. But over here, we're not supposed to print. We're not supposed to find the sum. We're supposed to count the multiples of 3 between 1 and n. So let me go back to IntelliJ. Let me open Q5 solution 1 and let me discuss how can we count, right? So what's going to happen is over here, I is going to iterate from 1 all the way up to n, right? So if n is 15, I will iterate from 1, then go to 2, 3, 4, 5, and so on, all the way up to 15. But what are we doing is we are printing only if the value of I is a multiple of 3, right? So if I divided by 3 gives 0 as the remainder, we are printing the value of I, which means we already have a code to assess if a particular value of I is a multiple of 3 or not, right? Now, what we have to do is we have to count. So instead of printing, we'll have to keep a track of count, right? Which means when I is equal to 1, this condition will be false. So the code inside the condition won't execute, which means we don't have to keep track of the count, right? But if I is equal to 3, what will happen? We'll have to write some code over here, which will keep a track of count and will set that to 1. So let's discuss how can that be done, and then we will write code. So taking n is equal to 15, for example, we will get 1, 2, 3, 4, and so on, all the way up to 15, right? And we know that the values of I, where dividing by 3 gives 0 as a remainder, are the ones that will get printed, right? So what we should be doing is, whenever the condition is true, we should be keeping a track of the count, right? So when the condition is true for the first time, the count will be 1. Then when the value of I is 6, the count will become 2, right? Then when the value of I becomes 9 over here, count will become 3. And then finally, when I is 15, count will become 4, right? So what we have to do is, every time the condition evaluates to true, we have to increase the value of count by 1. Now, to increase the value of count by 1, what can we do? We, of course, will have to take a variable called count, and we will have to initialize it to 0. Now, if you're wondering why initialize it to 0, the logic here is similar to what we discussed with sum. When I don't give you any number, the sum is 0, right? Similarly, until you have encountered the first value which you want to count, the count will be 0, right? That is why we will store 0 in the variable count. And when I encounter the first number, I will increase the value of count by 1. And that we know can be done this way. All we have to do is increase the value of count. So we can say count plus 1 and store it back in count, right? Or we can also say count plus plus, right? Both will do the same thing. So summarizing all of this, what we have to do is, whenever I mod 3 is equal to 0 is correct, taking into consideration that we are going for the first solution that we have discussed, we will have to go for count is equal to count plus 1 or count plus plus, right? So with this clear, let's come back to IntelliJ, and let me first of all copy the name. Let me create a new Java class, paste it here, change it to q6 underscore, and instead of print all multiples, we will say print count of all multiples of 3 from 1 to n, solution 1. Appropriate name. So let's create a class with this name, and let me grab the main method from q5 solution 1, and let me paste it over here. Now we know that we are not supposed to print over here. We're supposed to keep track of count. So we'll create a variable called count, which we will use to keep track of the count, right? And every time this condition is true, we will increase the value of count by 1. And that will indicate that we have found one more number, which is a multiple of 3 between 1 and n, right? So let me remove this and let me say count plus plus. And at the end of the loop, we're going to print the value of count, right? So for n is equal to 15, if I run this code, what should I get? The output should be 4. Actually 5, because we have got 5 numbers from 1 to 15, which is a multiple of 3, right? They are 3, 6, 9, 12, and 15. So let's run the code. And the output is 5, which is what we had expected. Now, if I change this to, for example, 14, I should get 4 as the output, because there are only 4 numbers from 1 to 14, which is a multiple of 3, right? And that is what we are getting. Now, let me quickly write the next solution too. So we'll say q6 print count of all multiples of 3 from 1 to n, solution 2. And over here, what am I going to do is, I'm going to grab the main method from q5 solution 2, and I'm going to paste it over here. And over here, like you see, the iteration itself will take care of the fact that we need only the multiples of 3, right? So every time we get inside the loop, that is every time the system.out.println I is getting executed, we can be very sure that the value of I is a multiple of 3, right? And if we are sure that the value of I is a multiple of 3, all we will have to do is just increase the value of count by 1. So with this code, we should be getting the correct output. So if n is equal to 15, we should get 5 as the output, and that's what we got. Now, if n is equal to 14, we should get 4 as the output, and that's exactly what we have over here. So I hope the solution to this question is understandable to you. And with that, we can mark the 6th question as completed, right? So we're done with 6 of the 9 questions that we had planned for the first category. Now let's move on to the next question, which is to print the first n Fibonacci numbers. Now, to attempt this question, we will first of all have to know what Fibonacci numbers are. So let me quickly Google search and let's go to Wikipedia. And let's read the first paragraph, which will tell both of us, that is you and me, what Fibonacci numbers are. So in mathematics, the Fibonacci sequence is a sequence in which each element is the sum of the two elements that precede it. I'll tell you what it means in a moment. And the numbers that are part of that sequence are called the Fibonacci numbers. And each Fibonacci number is denoted by Fn, where n is the nth Fibonacci number. Now, it further says that the initial elements of the sequence are 1 and 2. Sorry, 1 and 1. That is, the first Fibonacci number is 1 and the second Fibonacci number is also 1. And it further says that many authors also include a 0th element where what we have is f0 is equal to 0. So if we take all of this into consideration and we take a look at the Fibonacci sequence, this is what it is going to look like. Starting from f0, the first element, or sorry, the 0th element will be 0. Then the first element will be 1. Then the next element will be 1. And like the definition says, each element is the sum of two elements that precede it. That is, the two elements that comes before it, right? So if you take a look at this one, it is the sum of the previous two elements, that is 0 and 1. Or if you take any term over here, for example, 8, it is the sum of the previous two numbers, that is 5 and 3. The same thing applies to 89, for example. It is sum of 55 and 34. So now let us see how can we generate these numbers, because the question says we have to print the first n Fibonacci numbers, and we will be able to print only if we can generate, right? So for that, let's come over here and let's first of all see how can we generate Fibonacci numbers. Now, on the basis of whatever we have discussed, the Fibonacci number would start from 0, 1, and then would proceed from there. And this is assuming the 0th element that some authors or some mathematicians take. So let's take this definition. I mean, you can go for this definition where the first two terms are 1 and 1, and that also would be fine. But let's take this one. Now, over here, we have the first two numbers as 0 and 1, right? And we need these first two numbers in order to find the third number in the Fibonacci sequence, right? Because as we know, each number would be the sum of the previous two numbers. And if we don't have these two numbers, we won't be able to find this, right? So let's understand how can we do this. So let's say this is the current term or the current number that we are interested in, right? So to find the current term, what we need is the last term and the second last term, right? Because the definition says each term would be the sum of the previous two terms. So let's say this is denoted by LT, that is last term, and this is denoted by SLT, that is the second last term, right? Now, if this is second last term and this is last term, we need to find the current term. And current term is simply the sum of last term plus the second last term, right? So taking this into consideration, can we say that the current term would be 1? We can, right? Now, once we have found this term, what we would have to do next is we will have to find the next term, correct? Which means this current term will not store this, because we need to find the next term. What would happen is we will have current term point over here. So let's say current term is just a variable which holds the current term, right? Now, if this is what we have to find, we will have to keep track of this and this, correct? Because again, like we know, every term in Fibonacci sequence, of course, except the first two terms, will be the sum of the previous two terms. So if we are interested in finding this, we will have to know what the last term was, and we will also have to know what the second last term was, right? And we have taken two variables which will keep track of the last term and the second last term. But the problem is, if I make current term point to this, we won't be able to keep track of the last term, right? Because what's going to happen is current term, which was holding 1, has now moved to the next term, right? So what we will have to do is, once we have found the current term, which is 1 in this case, what we will have to do next is, before we make current term move to the next term, we will have to prepare last term and the second last term such that we hold this and this respectively, right? Because these two would be required to find this. So starting from first, current term is this, for example. And we found this by taking the sum of last and the second last term, right? And before we can find the next term, which is this, we'll have to ensure that last term and second last term holds the correct value, right? So considering this, the correct value for last term is this, and correct value for second last term is this, right? So what we will have to do is, we will have to store this value in last term. So can we say last term is equal to current term? If I do that, what is going to happen? What's going to happen is, last term will hold whatever current term is holding, right? Now, I said we'll have to prepare last term and we will also have to prepare second last term. So last term should hold this one, right? And second last term should hold this one. But we don't have a track of this because whatever was keeping track of this, which is LT, has now been moved over here, correct? So if we go for LT is equal to CT, after finding CT, we will end up losing this. And there won't be any way in which we can track the second last term properly, right? So what we should be doing is, instead of going for LT is equal to CT first, we should be going for second last term is equal to last term, which means the second last term is this, the last term is this, and the current term is this, right? So we should first of all make the second last term move here. That is, store the same value that the last term is currently holding, right? Now, since second last term is holding this value, last term can now hold this value, right? So we can then say last term is equal to second last term. So, sorry, last term is equal to current term. So LT will store whatever current term is holding, right? So with this done, what's happening now? Now, last term points here, second last term points here, which means we are ready to find the next term, right? So now this current term can freely refer to this. And when current term refers to this, we know the formula to find the current term, right? Which is last term plus second last term. And last term is 1, second last term is 1. So the current term would become 2, right? And we know what are we supposed to do after the current term. We're supposed to make the second last term and the last term ready for the next term, right? And to do that, we go for second last term is equal to last term. So what's going to happen is, the second last term will now hold whatever last term is holding. And then we say last term is equal to current term, right? So when we do that, what's going to happen is, the last term will hold whatever current term is holding. And then we will be ready to find the next term. So we can say this, right? So current term will be this. And again, current term is equal to last term plus second last term, right? So we'll have last term plus second last term as 3 in this case, we will say 3. Then we will make the second last term and last term ready for the next term, right? And we will do that by storing new values, which will be this, sorry, this and this. So this will become 5, and that is how we can proceed, right? So what did we learn here? We learned that we'll have to keep track of the first two terms separately, and then to find the next term, we can take the last term and the second last term, right? We can add them and find the new term. And then to find the next term, we'll have to prepare the second last term and the last term, right? So this would have given you an indication that the first two terms will be fixed, and the third term onwards, we can iterate, right? Because as you can see, these three steps are repeating, right? And because these are repeating, we can iterate for required number of times, correct? So with this clear, let me discuss the next steps. And before that, let me clear all of this. Now, let's say the value of n is equal to 5, which means we need to print the first 5 Fibonacci numbers, right? And the first 5 Fibonacci numbers would be this 0, 1, 1, 2, 3. And over here, 0 and 1 will get printed just like that, as in no calculations required. Then from the third term onwards, all the way up to the fifth term, we will calculate and we will print, right? So if n is equal to 5, we will print the first two terms directly and calculate and print the next three terms. If n is equal to, say, 7, we will do the same thing. Print the first two terms and then print third all the way up to the seventh term, right? But what if the value of n is equal to, say, 1? In that case, we will print only the first term, right? We'll have to make sure that we are printing only the first term. If n is equal to 2, we'll print only the first two, right? Only if the value of n is equal to 3 or more, we will print the first two and then start the calculation process, right? You must have understood, because if the value of n is equal to 1 or 2, there's no calculation needed because the first two terms are known and those are the starting points. Third term onwards is what we start calculating from, right? So with all of this clear, can we now go to IntelliJ and start writing the code? We can, right? So we will say q7 underscore print first n Fibonacci numbers. And what did we discuss? We discussed that we will need some value of n, of course. So let's take a value of n which is large enough, say 7, for example. And let's focus on the fact that n is greater than or equal to 3. Because if n is 1 or 2, we will have to handle it separately. But let's do that towards the end. For now, let's assume that the value of n is greater than or equal to 3, and let's write code accordingly, right? So what we will need is last term and second last term, correct? That is something we had discussed. Now, for starting, the second last term will be 0 and the last term is 1, right? Because this is how the sequence would be 0 and then 1. And this is what we are supposed to find. So if this is what we are supposed to find, the last term will be 1, and that is why we have initialized last term to 1. And the second last term would be 0, and that is why we have initialized second last term to 0. Then, like we had discussed, we will go for a loop, right? So the loop would start from 3 all the way up to n, because again, like we discussed, the first two terms are the starting point. So we will print them just like that. So we will say the first term, which is stored in the second last term variable, and then we will say the last term, which stores the second term of the sequence. And then we will have a loop. We will say int I is equal to 3. We'll go all the way up to n, because we need to print n number of Fibonacci numbers, right? Now, according to the formula, it will be current term is equal to the last term plus second last term, right? And then we had discussed that we will first of all make second last term hold whatever last term is holding before making last term hold whatever current term is holding, right? And over here, every time we have calculated current term, we can just go ahead and print the current term. So if I run the code now, what is the expected output? The expected output is 0, 1, 1, then 2, then 3, then 5, and then 8. Are these 7 terms? Yes. And it should be 5 and not 4. So this is what the output should be. So let's run the code and check. And looks like that's exactly what we are getting. We're getting 0, 1, 1, 2, 3, 5, 8. And if I increase the value of n from 7 to 8, I should get 13, right? And that's what we got. So we have taken care of the cases where the value of n is greater than or equal to 3. But let's also change the value of n to 3. Let's run the code and check the output before we proceed. And it says 0, 1, 1, which is absolutely correct, right? Now let's take care of the fact when the values of n could be 1 or 2 also, right? So if the value of n is 1, all we have to do is print the second last term that we have over here, which is 0. So let's handle it separately over here. Let's say if n is equal to 1, all we do is print 0, right? But if n is equal to 2, we print both 0 and 1, right? And if n is not equal to 1 and n is not equal to 2, which means n is equal to 3 or is greater than 3, we go for all of this logic that we have just discussed. So we'll put this inside else, right? So with this done, let's change the value of n to 1 and let's run the code. And we see only 0 getting printed, which is absolutely right. And let's say n is equal to 2, we should get 0 and 1, which is right again. And let's say n is equal to 3, we should get 0, 1, 1. When n is equal to 4, we should get 0, 1, 1, and 2, correct? And that is what we are getting. So this way, we can print the first n Fibonacci numbers, right? And I hope the logic made sense to you. Now, if you're wondering, why have I created current term variable inside the for loop, but the second last term and the last term variables were created outside the for loop? It is because current term depends on the value of last term and second last term, right? Current term is the sum of last term and second last term, which means by the time this line executes, last term and second last term should be created and should have a value, correct? So if I create second last term and last term inside the for loop, what would I have to do is I would have to create them over here, right? Say second last term and last term. Now, if I create the second last term and last term over here, I'll also have to initialize it, right? Because if I go for example, int current term is equal to second last term plus last term without initializing, we will see that we are getting errors. And that error will say that the variable might not have been initialized. So if I create second last term and last term inside loop, I will not be able to use it in current term without initializing. Now, if I initialize this to some value, for example, 0 and 1, what will happen? Every time the loop iterates, the second last term variable and the last term variable will get created and they will be initialized with 0 and 1 respectively, which will happen every single time. But what do we need is, we want second last term and the last term to hold different values in different iteration, right? In the first iteration, it will hold 0 and 1. And in the next iteration, it will hold 1 and 1, right? In the next iteration, it will hold 1 and 2 so that it can calculate this term, which will be 3, right? That is why we cannot do it this way. However, regarding current term, this can either be created inside the loop or it can be created outside the loop. It won't matter because current term anyway relies on the sum of last term and the second last term. So you can create it over here and you can use the variable inside the loop this way and it will work absolutely fine. So with this, we are done with the 7th question from the list. So let me mark this as completed. And the next question that you can see over here is similar to the question that we have just solved. In the question that we have just solved, we have printed the first n Fibonacci numbers. But over here, we have to print just the nth Fibonacci number. That is not the first, not the second, not the third. Assuming the value of n is say 5, we have to print just the fifth Fibonacci number and not the first, second, third, and fourth. But to get to the fifth Fibonacci number, we will have to calculate the fourth, right? Which means we'll have to calculate third, we'll have to calculate second and first also. So the logic is going to remain largely the same. It's just that we won't print all of them, right? So let's come back to IntelliJ. Let me copy the name of the class. Let me create a new Java class and name this as Q8 underscore print. Instead of first n Fibonacci numbers, I'm going to say print nth Fibonacci number. And over here, what am I going to do is I'm going to grab the main method that we have, because like I said, the logic will largely be the same. So let me close this. Let me paste the main method here and let's start working on the code. So if n is equal to 1, we should be printing just 0, right? So this part of the code is absolutely fine. Now, if n is equal to 2, we should be printing just 1, not 0 and 1. We should be printing just 1, right? Then if n is equal to 3 or more, we should be calculating up to the nth term and we should be printing just the nth term, correct? So let's see how can we do that. So over here, we have a way to print all the terms up to the nth term, right? But what we want is we want to print just the nth term. So what is that one tweak that you can make over here, which will print just the nth term and not all of the terms? So in the else, first of all, we'll have to get rid of these two print statements because we don't need them over here, because we are in else, which means the value of n is greater than or equal to 3, which means we don't need to print the first and the second term, right? Now over here, what are we doing is we're iterating from 3 all the way up to n, and we are printing in each and every iteration. But what if I do this? If I go for if I is equal to n, only then print the current term. Will this solve whatever we are trying to solve? I think yes, but let's run the code and see. So if n is equal to 4, we should get just 2 as the output, nothing else, just 2. And that's exactly what we got, right? If I change the value of n from 4 to say 7, what should I get? I should get 8 as the output because 8 is the 7th Fibonacci number, right? And if I change this to 8, that is n is equal to 8, I should get 13 as the output because 13 is the 8th Fibonacci number. So this code seems to be working absolutely fine. We will keep on calculating the current term because of course we need it, and we will print if and only if we are on the last iteration. So this is one way of solving it. Is there a different, cleaner way to do this? That is print the nth term, but without the use of this if that we can see over here. Well, there is. What if we calculate each and every term, right? And once we reach the last term, this loop will terminate, right? Now, after this loop terminates, the current term variable would hold the last calculated term, right? So let me tell you what I mean. Now, before I write the code for the new solution that I'm discussing, let me first of all refactor this. And let me name this as solution 1. And let me copy the name from here. Let me say new Java class Q8 print nth Fibonacci number solution 2. And over here, what am I going to do is I'm going to grab the main method, close this, paste it over here. So what I was saying was, instead of using this if block that we have, is there a cleaner way to do this? Well, there is, and let me tell you what that is. So after the loop terminates, if we are here, what does that mean? That means that all of the n numbers of the Fibonacci sequence has been calculated, right? So if we calculate all of the n numbers of the Fibonacci sequence, we can print the nth number, right? But the next question is, where will the nth number be stored? So if the loop has terminated and we are over here, the nth number of the Fibonacci sequence will be in the current term variable, because in every iteration, current term is holding the ith term of the Fibonacci sequence. So in the last iteration, for example, 7, assuming that the value of n is 7, current term would be holding the 7th Fibonacci number, right? So we can use this current term to print the last Fibonacci number. The problem is we have declared current term inside the for loop. So what we can do is we can declare the current term variable outside the for loop, and we can get rid of this int over here in line number 20. Now, if I do that, I still get an error, and that error will say that the variable current term might not have been initialized, which means we have created the variable outside the for loop, but it is only getting initialized inside the for loop, which also means that if the for loop never executes, current term will not have a value because we have not initialized it. And that is why we are getting an error, right? So what should we initialize current term to? We can initialize current term to 0, right? And that will not be a problem. So if I initialize current term to 0 and then run the code, taking the value of n is equal to 8, we are getting 13 and 13 as the output. And this is printing twice because we still have this piece of code inside the for loop. So let me get rid of this and let me run the code again. And we can see that it prints 13 just once. Now, if I change this to say 5, what will I get? I'll get 3 as the output, right? And we got 3 as the output, which means the logic is absolutely correct. Now, there's one point that I wanted to discuss about the value that current term is initialized to. So we have initialized current term to 0. Now, if you take a look at the Fibonacci sequence, 0 is the first term of the Fibonacci sequence, which means current term is in a way holding the first term of the Fibonacci sequence. But that should not be the case, right? Because the first number of the Fibonacci sequence is in the second last term variable. So current term variable should initially hold a value that indicates that it has got nothing. That is, it has not got any term of the Fibonacci sequence, because current term is getting calculated inside the loop. So only inside the loop, current term will have the correct value. Outside the loop, it should have a value that indicates that the current term has not been calculated yet, right? Similar to sum that we had discussed. If sum is not calculated yet, it has 0, which indicates that no number has been given, so no sum exists as of now, correct? With the same logic, current term holding 0 would indicate that current term is holding the first term of the Fibonacci sequence, which is not the case. Current term is holding the third term onwards, right? So we can say current term is equal to -1, indicating that current term does not hold any valid value of the Fibonacci sequence. Now again, initializing current term to 0 is not a problem. The code will work absolutely fine, but it just goes against the convention. And that is why I have initialized current term to -1. So if I run the code now, I should get the same output that I got the last time, which is 3, taking n is equal to 5 into consideration. And if I change this to 8, I should get 13. And that is what we got. So with this, we're done with the second last question, which is given a positive integer n, we're supposed to print the nth Fibonacci number. Now on to the last question, which is to compute the factorial of n. Now again, before we get to how to solve this, let's discuss what factorial of n is. So factorial of n is denoted by this, and this is the product of numbers from 1 all the way up to n, right? So what we have to do is we have to get 1, 2, 3 all the way up to n, and then we have to multiply, and all that we will be given will be the value of n. Now this is similar to what we did with sum, right? We were given value of n, we got all of the numbers from 1 to n, and then we found the sum, right? So the only thing that is changing over here is instead of finding sum, we are supposed to find the product. So the code can largely be the same, right? Now the only change that will be required is over here, what did we do was, we first of all did sum is equal to 0, and then later inside the loop, we went for sum is equal to sum plus I. Now if I do the same thing over here, it won't work, of course, because we are supposed to find the product and not the sum. So this sum is equal to sum plus I will change to what? It will change to product is equal to product multiplied by I. because we're supposed to find the product and not sum. Now, another question that arises is, in case of sum, we had initialized sum to 0. So what are we going to initialize p or the product variable to in case of product? So going by the same logic that we had taken in finding the sum of numbers from 1 to n, that is, we took the additive identity to initialize the variable sum. We will take the multiplicative identity to initialize the variable product. So p is equal to 1. And like additive identity, multiplicative identity is a number which, when multiplied with another number, gives the same number. So if you have p and you want to multiply p with a number such that the result is p, what would that number be? That number will be 1, right? And that is why we're initializing p with 1. So with this discussed, we are now ready to write the code. So coming back to IntelliJ, let me create a Java class and let me say the name as qn underscore factorial of n, right? Now over here, what are we going to do is, I misspelled factorial. It should have been Factorial. So over here, what are we going to do is have a main method, take n and initialize to say 6, for example. And then like we discussed, similar to finding sum of numbers from 1 to n, we'll take a variable called product. We will initialize this to 1 because multiplicative identity. And then we'll say for int I is equal to 1, I less than equal to n, I plus plus, we'll say product is equal to product multiplied by I. And then we will say system.out.println product. So if it is 6, what will happen is it will find 1 into 2 into 3 into 4 into 5 into 6, which is 6 factorial, right? And 6 factorial would be 6 into 5, 30. 30 into 4 is 120. 120 into 3 is 360. Into 2 is 720. So we should get 720 as the output. And that is exactly what we got. Now, if I change this to 7, it would be 720 into 7, which is 5040, which is what we should be getting, right? And then changing to 8 would give us 40,320. And that's what we got. So this is how we can find the factorial of a number. Now, as you might have observed, the factorial is increasing pretty fast. For example, if I have 6 over here, it is a 3-digit number, which is 720. If I have 7, it becomes 5040, which is a 4-digit number. 8 makes it a 5-digit number, which is 40,320. If I change this to 9, it is going to be 362,880, which is a 6-digit number. So that means that if we take a very large value of n, 100 for example, we will not get the correct output, as you can see, because the value of 100 factorial is way more than what int can hold. So a way to solve that is to take long over here and proceed with it. Now, even with long, if I take a very large number, this will not work. And this is because a very large value of n will lead to a very, very large number, which will go even beyond the maximum value that long can hold. So there's a way to solve that as well, but then we'll not discuss that for now. For now, we'll just focus on the fact that we are trying to be comfortable with iteration. So let me revert the code and let's say int n is equal to 9. So with this, we're done with the last question that we were supposed to solve in the fundamental loop patterns category. So I hope that you have been able to understand the logic that I have discussed, and I hope that you are getting comfortable with iteration statements. And in the next video, what are we going to do is we're going to solve questions in the digit extraction patterns, where we will take a number, we will extract digits from the number, and we will process those digits to solve some of the questions that I have listed down over here. So with this, we come to the end of the video. I hope I've been able to teach you something new and useful. If you have any suggestions, feedback, or queries, feel free to put them in the comments. Thank you so much for watching, and I'll see you in the next one.